Okay, so the next problem here is you're playing with fireworks on 4th of July, and one was launched from ground with an initial velocity of 60 meters per second at launch angle this, and it's programmed to explode when it reaches the max height, and assume there's no resistance or whatever, and the gravitational acceleration at 10 meters per second squared. So we can kind of visualize what's going to happen. So from the ground, this thing will be launched with an angle that was 75 degrees, like that, right? And then this guy will go up and 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 up like that, and then at this point it will explode, right? When it reaches at the max point. So what we are looking for is how far horizontally, what's going to be this distance, and what we're looking for is what's going to be the max height. This height. Those are what we're looking for here. Okay? So we did not have anything very exactly same as this, of course, but in the lecture note we had that boy kicking a ball and it landed down, something like that. So this thing and that thing, it's basically the same type of problem. So let's try this thing together. And it's a ballistic motion type of thing, so we're going to be using that kinematics rules. So first thing, I'll just write that thing down. S is S naught plus and this thing is, there's the acceleration is a constant, right? So S naught v of t plus 1/2 at squared, and v is v naught plus gt, or at, and yeah, at least we can use these two, and those are all, where is it? It's provided here, so you guys can utilize these things. And then we can now try it in two axes, x and y directions, right? So which one should we try first? So in the x direction, there's no acceleration, right? So s of x is, if we set our axis here, x and y like that, then this guy is going to be 0, so it's going to be just v of x times t. And v, we're not interested in v, so we don't even need to talk about that. And in the y direction, s of y is v of y times t minus 1/2 g t squared, isn't this? Right? And then what else do we have? V of y is v of y minus gt. Right? So we will need to find out these two values. And of course we can find it out from here. If this was 60 and the angle was 75, then we have this component and we have that component, right? So this is VO of x and this is VO of y, and this value, how do you find? This is 75, is it sine or cosine? It's cosine, right? Cosine 75 degree, and this is, oh sorry, it's 60, right? So 60 times, and this is 60 times sine of 75 degree, right? So from here I think we have all the information. Now we need to use our brain to solve something. What do we need to do? When it reaches at the max height, what's going to be the hint? Yes, this guy would be 0, wouldn't it? Right? So at max point, v of y, vy is 0, so 60 sine of 75 degree minus g, did I assume something? Yeah, we assume 10, so 10 times of t is going to be 0, right? So from here, we should be able to find the t, and if my math was correct, we get it like 5.8 second, something like that, right? And then we need to find the max height. So from here, we can find the max height, right? So by applying this over there, max height h is VOY 60 times sine 75 degree. That value times the t, which is 5.8, minus 1/2 g is 10, and t squared, 5.8 squared. That going to give us the max height, and that value would be something like 167 meter. So we found this value, and so we're done with this, and we need to find the horizontal distance. So from here, how far it will fly and then explode. So we need to find this thing. And that one, we can also use distance d is VOX, which is 60 times cosine 75 degree, and that guy times this time, 5.8 second, and this may give us something like 90 meter. So that's going to be this. Okay, so we're done with that too. Okay, so just to summarize this thing one more time, it flies up and then goes up there, and when it reaches at the max point, it explodes, right? And because this is just a simple ballistic motion, you want to think, oh, we need to use these equations. So I'll just write those down, or just have it handy. And then we want to set our axis, x and y, setting our axis like that. Where it starts, it's going to be easy. That way we can define the distance and height easily like that. So once we have it, we're applying these in the horizontal and the vertical direction, right? And in the horizontal direction, there's no acceleration, so we only have that equation. And in the vertical direction, we have this. But note that g is a minus value because we define this as a positive, but gravity is minus, right? Going down, so it's a minus. Okay, I've seen some of you using this positive, and all the number got messed up. Okay, so this is minus there, and now we're using the hint that at the max point your vertical velocity is 0. So from there we can find the time when it explodes, and by using this we can plug it in here to find the height, and by plugging it there to find the distance. Okay? All right. Any questions up to here? Okay, now let's move on. And then the next one here, this is coming from from the problems in our notes, and also you see this is coming from our textbook thing. What was that? The homework problems. So a truck is traveling along a horizontal circular curve with a radius of 60 meter and it has a constant speed of 6 meters per second, and we want to find out the magnitude of the truck's acceleration. Okay. okay? And the hint provided was use the NT coordinate system. So it was about the acceleration. So acceleration is a of t ut hat plus a of n un hat, and a of t is v dot, and a of n is v squared over rho, right? And I believe that's all provided here as well. Here, right? So by setting that, and of course we have this is my t direction and this is my n direction, right? Those are pretty straightforward. And so if we want to find the magnitude of this a, all we do is at squared plus an squared and square root. That's it, right? So we need to find out these two values. So what's going to be the value of at in this case? Yes, derivative of the velocity, and it said it is nothing there. Oh, it says it's a constant speed, right? So this guy is 0 because it's a constant speed there. Okay. Right. And in that direction, it has a constant speed there. And this one, we're just plugging in 6 squared over, what's the radius? That's 60, right? So we just plug in that. This is what? 36 over 60. And this is 6 over 10, so it's 0.6. So basically, we don't have this. Therefore, this is just 0.6. And don't forget the unit, meter per second squared. Okay? So this problem is a pretty straightforward one, and many of you did well. And some of the mistakes I remember is about this part and noting that it has a constant speed, so it has to be 0. Okay? But any questions up to this part? Okay, not. Let's move on. And then here, let's see, yeah. Girl swinging. Yeah, this one is also coming from our lecture note, and has a max height defined by this angle 30 degree at which she's momentarily at rest and neglecting any friction as well as mass of all those things. The system could be modeled as a simple pendulum like that, right? And gravitational acceleration is 10, and assuming potential energy is 0 when theta was 0. So we just set this as our datum, okay? And we want to find out the following. So the potential energy when it is at this point. So potential energy V is simple, mgh, isn't it? And so from this point, we need to find the h like that. So this one may require a little bit of geometry, like this. And this is 30 degree, right? And what was the length? It's 2 meters. So this is 2. This is, what's going to be the length of this guy? That's going to be 2 times sine 30 or cosine 30? Cosine 30, right? And so this distance is going to be 2 minus 2 cosine 30 degree because the whole length was 2. This thing just swing and goes up like that, right? So we can find the height as this value, and then all we need to do is just plug that in. So many of you did pretty well on this. The the ones who made mistake was finding this guy with the wrong value. That was some of the mistakes that I remember. So we can plug in all the numbers now. M was 30 kilograms, so 30, and G is 10, and then H is 2 minus 2 cosine 30 degree, and my math was correct. It should give us something like this. Okay? And then next, we want to find out the speed when the girl passes this point, okay? And if you want to do that thing, we can use this energy principle. T1 plus V1 is T2 plus V2. So that we can call it here at point 1, and when it's down there, it's point 2. Right? And so the kinetic energy at point 1, this guy is going to be 0, right? Because when she goes up there, she basically stops for a moment when it reaches the max height. So there's nothing there. And when you are down here, our potential energy is going to be 0, because we also assumed that potential energy is 0 when it's at 0 angle. So all we have to do is just basically solve this. So 80.4 is going to be 1/2 mv2 squared. So if you do the math, V2 should be something like 2.3 meter per second. Okay? Any questions up to here? Okay, so if not, let's move on. And then we want to find out the appropriate coordinate system and free body diagram, F equals ma in each direction. And then what the tension and the supporting cord. Yes, we want to find the tension of the supporting cord of swing when theta was 0 degree. Okay. And note that the swing has 2 cords. So when this is at 0 degree, and then it is moving like that, right? Then we can draw a free body diagram, something like that. This is tangential and this is normal, let's say. And all the forces we have is mg and the tension that we have there. Therefore, along the n direction, where going up is my positive, sigma f is going to be T minus mg, and that's going to be m times a of n, right? And yeah. So using this T is going to be mg plus m. What's this a of n? That guy is v squared over rho, right? So m v squared over rho. So it's going to be, we can plug in numbers here, which is 30 kilogram 10 plus 30 times v is 2.3 squared over rho. It's just 2 meter, like that. And it should give me something like 380 Newton. However, like I mentioned in class, we have 2 strings. So it's hard to draw this thing, but the girl is going down like that. So this tension T is actually 2 of I don't know, T dash. Let's say you have T dash here and you have T dash there. So the final answer is going to be 190 Newton each being applied to the chords. Okay? Does that make sense? So up to here. Any questions? All right. Not. Let's move on. And this thing is coming from the textbook. And actually, we tried something similar in chapter 13 and 14. Like in 14, I believe we had a slope like that, and it's going down like this, and we want to find out when it stops and so on, right? So there's 25 kilogram block, and you have a force like this, and when S is 0, the block is at rest and spring is not compressed, and we assume gravity is 10 and friction coefficient is 0.25. And show your coordinate system and free body diagram, do F equals ma, and then determine the acceleration when S is at 0.2, and we want to find out the displacement when the block stops, and that's it. So let's do these two first. The coordinate system is pretty straightforward. You can just use it like that, x and y, isn't it? That's straightforward. And then we can do the free body diagram, and let's draw the free body diagram here like that. And then of course we have mg, and we have the normal force, and then we have that force being applied 500 Newton, and this was that 345 angle, so this is actually 400 and this is 300, right? You can maybe get rid of that if you want. And we have the spring, and we have friction like that. And spring force is K times S, right? And friction is mu times N, isn't it? So we got that free body diagram here as well. So once we're done with that, we want to do this F equals ma in each direction. So sigma F of x, and going to the right is my positive direction, and that's ma of x, right? So from here, we're collecting all the horizontal forces like these. So 400 is a positive minus fs minus fr, right? That's going to be ma of x. And in the y direction, sigma f y, where going up is my positive direction, ma of y, we have, and in this case, n is going up, minus mg minus 300 is going to be basically 0, right? So from here, it's going to be 400 minus fs was k times s. K is 500 as well. 500 s minus, this is mu times n. So we need to know that n, which is going to come from here. So let's try this thing first. N is going to be m times g. M is 25. And g, we assume it was just 10 plus 300. So this is going to be 250, 550 Newton. So I can use it up there, which is mu is 0.25 times n is 550, that's going to be ma of x. Okay, so we have this equation that we can use for the next steps. But basically, these are those f equals ma in each direction. Okay? So after that, now we can utilize these to solve at least some of these problems. So determine the acceleration, magnitude, and direction when s is 0.2 meter. So we want to find out this guy. So s is 0.2, therefore 400 minus 500 times 0.2 minus 0.25 times 550 is, what's my m? Is 25 times a of x. And if I do the math, this should be something like 6.5 meter per second squared, and it's a positive value, so it's going to the right direction. Okay, so that was pretty straightforward. And then the next one, we want to find out when the block stops. Okay, so we can try this T1 plus summation of all the work is going to be T2, this work and energy principle here. And initially, T1 is going to have a value of what? It starts with a velocity, or is it at rest? Yeah, the block it as rest. So this guy is going to be 0. And T2 is when the block stops. So that's going to be 0 as well. Right? So we can just find this work, summation of all the work. And here, the summation of all the work is done by these forces. So it has 400 times distance s when it's going to stop, right? F times s, and minus the work done by the spring is 1/2 500 spring squared, right? And then the next one is going to be 0.25 times 550. I don't have that value, but we just multiply s, and this basically has to be 0. Or if you want, you can just integrate this guy. 0 up to s, 400 minus 500 s minus 0.25, 550 ds. That's going to be the work, right? And actually that's this value. So from here we can get rid of the s, one of the s, and this s by dividing both sides. And from here, if you do the math, s is going to be what? Where is it? Should be 1.05. And it's meter there. Okay? All right. So, any questions up to here? So, you need to set your axis and do the free body diagram, F equals ma in each direction, and then use these information to solve some of these, basically. All right? Okay. And then let us move on. And this one, this is also similar to that baby, a boy kicking a ball in the textbook. and then it hits the ground, right? Instead of a kid kicking the ball, now there's a baseball player hitting a ball, right? So there's this barrel clarification and I don't know, baseball savant, or those stats they use. And it exhibits a great chance of being a home run, and find the following of a batted baseball, 150 gram, with an exit velocity of 144 kilometer per hour at an angle of 30 degree, okay? And this is classified as one of the barrel hits. And here we assume the acceleration is 10, and we ignore all other weird losses or practical things that we see in real life. And first, we want to determine the kinetic energy of the ball immediately after it is hit. Okay, so we want to find the kinetic energy of the ball at this point. Alrighty, so that's nothing but kinetic energy T is 1/2 mv squared, like that, right? So this thing is gonna be 1/2 m is 150 gram, which is 0.15 kilogram, right? And the velocity has to be in meter per second, so we need to convert this thing in meter per second. So this is 144 kilometer per hour, which is 144 kilometer is 1,000 meter, per hour is 3,600 second, right? So if my math was correct, it should be something like 40 meter per second. So we're going to provide 40 meter per second squared in there. And if you do the math, it should give us like 120 joules. So that's the kinetic energy right after it's hit. And here I remember some of you got this thing. One of the common mistake was a conversion issue, made a mistake there, or you got this value but you forgot to square it. Here you write it correctly but you just forgot to square it like that. Or some use instead of 1.15 gram, use 150 gram, those issues. Okay, so and I also remember some of you found the horizontal component of this velocity and just use this when you do velocity squared. But here we're not considering any directions or anything when you are usually dealing with the energy. Right? So that's that here. Okay? And then next question is about the max height above ground it reached by the ball. So it will start from here, right? And then it will go up, then it will go down. So this is what we're looking for, of course. And yeah. So some of you guys use energy principle, like T1 plus V1 is T2 plus V2. Like, let's say you use this is 0.1 and this is 0.2. And when you were doing this, some of the students were making the kinetic energy here to be 0, or kinetic energy here is 0, like that. But unfortunately, this was the main issue for those students when they assume this is 0. It is wrong. The reason why is vertically it's pauses, right? But there is still this horizontal component, right? So this is still flying with horizontal velocity component. So at this point, the kinetic energy is not 0. Okay, so if you just simply assume this guy to be 0, or you just put a 0 there, then this formulation would have given you a wrong answer. Okay, so that's one thing that I wanted to point out. And so let's try to find a max height, and we can think this thing as that ballistic motion again. So S is S naught plus V naught T plus 1/2 AT squared, and V is V naught plus AT. You can use these equations, right? And we are going to set our axis here and there, X and Y. So in my X direction and in my Y direction, well, we can maybe focus more on the Y direction because we're looking for the height here. So S of Y is S0 plus VOY times T minus 1/2 GT squared. And V of Y is V0Y minus GT. Right? And the key we want to use is when at max point, velocity of y is 0. So like I said, it goes up and then it pauses and then it goes down. So this guy becoming 0, that's something we want to use. So y, Vy is VOY. That's what we want to find out. So the velocity, it was 40 meter per second, and this was 30 degree. So we have two components, and this is VO of y, right? And that guy is going to be 40 times sine 30 degree. So that's basically 20, right? So 20 minus 10 times t is going to be 0 from this equation. So from here we find t is 2. And so I can plug that in over there, which will give us S of y is the initial displacement. Remember, it is flying from 1 meter above the ground, right? So that's going to be 1 plus VOY is 20 times 2 minus 1/2 10 2 squared. And just plug in all the numbers in here. This guy is 20, time is 2, 1/2 g times 2 squared. So if my math was correct, we get 21 meter. Okay, so we get our value here like that. And the kinetic energy, excuse me, when the ball reaches at its max height, it's T1 plus V1 is T2 plus V2, right? And T1 is going to be 120 joule, just like we obtained. And V1, we're going to do MGH, so MGH1 is T2, this MGH2, and from here 120 plus MGH1 is, what's my M, is 0.15 times G is 10 times H1 is 1 meter, right? So it's 1 is T2 plus m is 0.15 times g is 10 times h2 is my max height, which is 21. So from here, what we get is 90 joule, if my math was correct. Okay? Does that make sense? Any questions up to here? All right, now let's move on. Then how far will this guy fly and fall to the ground? So we actually need this x component then. So v of x is constant, v o of x, and s of x is VO x times t, right? And S of y is S naught plus V0y times t minus 1/2 GT squared. So first, we'll try to use the fact that when it hits the ground, the vertical displacement is going to be 0, right? So 0 is going to be initial displacement, which was 1, plus VOY, it was what? It was 20, right? 20 times t, that I don't know, minus 1/2 10 times t squared. Right, so from here we get that equation, it's going to be 5t squared minus 20t minus 1 equals 0. So we need to solve this equation, and it should give us something like 4.05 second. So it means when you hit the ball, it takes 4.05 seconds to hit the ground. Okay, so now all we need to calculate is by putting this t over there to find the distance, the horizontal distance. So if we plug in the number here, VOX was 40 times cosine 30 degree from here, right? And that times the time we just find out, and if the math was correct, we get something like 140 meter. Okay? And finally, we want to find out the velocity when the ball hits the ground. And so v of x and v of y, we need to find out. And v of x is going to be nothing but a constant. When this guy flies, the horizontal velocity remains the same, right? However, the vertical velocity was large and getting smaller and smaller and smaller and stops, and then it's getting larger and larger and larger and larger and larger like that, right? So this value is easy. That's nothing but 40 times cosine 30 degree. And v of y is something we need to calculate, v o y minus gt. And when the ball hits the ground, the time we just found out from there, so it's 40 sine 30 degree minus 10 times 4.05. the values should be something like 34.6 meter per second, and this should be something like 20.5 meter per second. So the velocity magnitude, if you want to find out, 34.6 squared plus 20.5 squared, and it has to be something like this value we got, around 40, right? At this point it was 40, so at this point it should be 40. That way energy conservation works, but it falls down a little bit more, so at this point it should be 40.5 or something slightly greater than that, 41, or I don't know. Okay, but if you found like 29 or 38, then it doesn't make sense, right? It's started from here, it reaches the same point. At that point it has to be 40, but it's going down a little bit more, so it has to be a little bit greater than that. Okay, so if you got some value like these, those are a good sign, but if you got something like that, it doesn't make sense. So those kind of things I want you guys to think about. Okay? All right, any questions down here? All right, and then let's move on. And there was this bonus, and some more than just more than half student, I believe, tried this one, but there were a few who didn't even try. So I would highly recommend you guys really just try. It's like a additional point. If you, even though you don't know, you just try something, then you get some partial credit. Okay, that's going to be helpful, especially toward the end of the semester when you're looking for your final letter grades. Okay, so here in the figure, A is moving upward 2 meters per second, and C is moving upward 5 meters per second, like that. And then we need to determine the speed and the direction of point B. Okay, so it feels like it may go down because these two are going up, so it may need to go down, but I don't know. Let's just find that thing out. So first thing is setting the axis, right? And where do you want to set your axis? You want to set your axis where, excuse me, it is not moving. So these are not moving, right? These pulleys are moving up and down, but these two are just fixed. So I will set my axis there, and then you want to set your direction towards the moving part as a positive. That's usually the easy way to do. Okay, so this is my positive direction, and then we want to consider the total length of the cord, right? Because that's going to be a constant. So I can call this guy as SA. These two are SB, and these two are SC. And I have this guy, this guy, this guy, this guy, this guy, and that guy not changing at all, right? Even though this moves up and down, this length colored by black is not going to change, right? So what we have is SA plus 2 of SB plus 2 of SC plus that black lines is going to be a constant, right? And so from here we get V of A plus 2 V of B plus 2 V of C is going to be 0. And now we want to plug in the numbers, and V of A is what? It's minus 2, right? this is my positive direction, but it's going up, so it's an opposite direction, so it's -2. And this guy is -5. So -2 plus 2VB plus 2 times -5 is 0. So it's this 2 and this 10, so 2VB is 12, so VB is 6 meter per second. And it's a positive value, so it's following my direction, so it is going down. Okay? Does that make sense? All right, any questions up to here? Okay, so let me stop this.